and on acidification that alcohol is being produced. Now this alcohol further followed by the oxidation with the NaOCl, it fetches you acetic acid. This is being given in the question. So 2 points you can make out over here is that first of all the basic structure of an ester, and the second point that is of the reaction of the basic structure, or you can say the ester with the methyl magnesium bromide, which is basically a Grignard reagent. So therefore, if let us see the reaction of an ester, first of all with the methyl magnesium bromide. So now the product in this case, what will be happening is that the CH3 group in the Grignard reagent will act as a nucleophile, and that will attack on the carbonyl group or the carbonyl carbon, that is C double bond O of an ester. Now if you see the reaction, that is the reaction of R C double bond O, OR dash with CH3 MgBr, the product formed will be this, that R C double bond O CH3. Now this actually is a ketone. And because the reaction of the Grignard reagent with the ester, when it undergoes, because in the ester we have this OR dash group, which actually is a good leaving group. So when the first molecule of the Grignard reagent attacks, what happens is that this OR dash group of the ester is basically eliminated. So due to which the product formed by the or you can say the product formed by the reaction of an ester with the first mole of the Grignard reagent fetches you a ketone, as well as in this step this OR dash group is being released. Now if you react this ketone, that is R C double bond O CH3 with the another molecule of the Grignard reagent, which is CH3 MgBr, so what will gonna happen is that the CH3 minus again will behave as a nucleophile and will attack on the ketone now. So due to which the product formed will be actually this, that is R C CH3 OH. Now this alcohol is basically a 3-degree alcohol. Now if you see the further question, it says that alcohol B reacts with the NaOCl. Now I told you that this NaOCl is basically a reagent for the haloform reaction. So if a haloform reaction has to undergo in the alcohol, then in that case the alcohol should be a 2-degree. Whereas the alcohol which we have obtained, that is RCCH3 OH, is basically a 3-degree alcohol. So therefore first of all what you need to do is that you need to form this alcohol as a 2-degree first of all. Now if you want to convert this alcohol into a 2-degree alcohol, what you should think about it is that that in this case, in this alcohol, the two CH3 groups are basically coming from the Grignard reagent. The only group which you can modify over here is basically the only R group. So therefore, if you assume R is equal to H, then in that case your alcohol will be a 2 degree, and hence the structure of it will be basically CH3 CHOH, and you will be having another CH3. Now if you assume this, that R is equal to H, then you also replace R by H in the basic structure of an ester which we have presumed. So the basic structure of the ester which we have presumed is basically R C double bond O, OR dash. Now if you replace this R by H, then you know what is the possibility of the structure of an ester is this, that it is H C double bond O, OR dash. Another point again which is important over here,